Welcome everybody, and thanks for attending today's webinar, The Road to Zero Emissions, Building a Sustainable Fleet. My name is Mary Ellen Kennedy, and I'll be moderating for today's presentation. We're going to go ahead and get started in just a second, but first I would like to say that we're very excited to have Nick Bridle with us as presenter today. Nick has been working in the fleet industry for over 42 years and currently serves as a senior industry advisor at AssetWorks. Before we get started, I want to give everyone a quick heads up. All the microphones have been muted, so if any of you have any questions at any time during the presentation, you can use the WebEx chat tool. You should all see the chat icon located on your screen, and this acts as an instant messaging tool. Please feel free to use the WebEx chat tool to enter any questions during the presentation, and make sure you send them to host, and I'll be happy to field and relay them to Nick at the conclusion of the presentation for a brief Q&A session. So with that said, I think we're ready to get started here. So Nick, you are the presenter and you're sharing your screen. So I'm just going to pass this over to you and you can just get started.
Okay, thank you, Mary Ellen. Good afternoon to you all and welcome to the Road to Zero Emissions, Building a Sustainable Fleet webinar. Okay, so our agenda today, we're going to cover the current state of sustainability in the UK and look at the key drivers for change. We're going to have a look at fuels and vehicle types, battery electric vehicles versus fuel cells, and then finally, how to prepare your fleet using data. So understanding your life cycles, forecasting your plans, and scoring based on criteria. So the current state of sustainability. So what lies ahead? So battery electric cars are expected to triple over the next 3 years, with 214 EV models being made available by manufacturers. And if there's going to be circa 100 million cars on the road by 2025, and 7% are BEVs, that's 7 million cars. So there's a significant change on the horizon for the transport industry. So what are the key drivers? Our European legislation. So car makers are now targeted to reduce the average CO2 emissions across the industry to 95 grams a kilometre. The phasing period begins in 2020, and from 2021, the average emissions of all newly registered cars by individual manufacturers will need to be below 95 grams a kilometre on average. So if a manufacturer exceeds its target, they face a fine for each 1 gram per kilometre of target exceedance for each vehicle registered. And if you're running a large fleet, that could be up to 500 million euros. And the same for the European truck manufacturers. They must reduce their CO2 emissions of their products by 15% by 2025, based on 2015 baselines. The UK government issued its Road to Zero report, and the UK was to become the first major economy to commit to net zero carbon emissions by 2050. It is now calling for the end of the sale of petrol and diesel or internal combustion engine cars and van sales by 2035 instead of 2040. And that said, the Committee for Climate Change is challenging the government and would like these targets brought forward to 2032. So the government has set up the COP26 summit in November in Glasgow to review as part of the annual UN-led gathering, and that's the Climate Change Conference. Okay, legislation for clean air zones. In 2021, London's ultra-low emission zone will be extended from the congestion zone to the North and South Circular. Birmingham and Leeds have CAS areas planned for June 2020. Oxford has a zero emission zone planned for December 2020, and the government is still challenging several other cities to develop clear air zone policies in 2020. So many local councils are now declaring air quality issues and climate emergencies as they grapple with the plan to reduce their effect in carbon emissions in their cities and the NOx. So, and we should also note, much of this legislation and development is currently focused around the car market. The commercial market vehicle development needs to catch up, and very fast, as 20% of the vehicles cause 80% of the pollution in and around our cities. And clearly, the NOx has a big effect on human health. So, sorry, I'm on the wrong slide. So what support do we need to see from the government? We need a coordinated national network of clean air zones with common local authority standard approaches. They're currently a little disjointed and confusing. So Euro 6 is seen as clean and acceptable in CAD zones, but Bristol is planning on banning diesel vehicles from the city. So we need some common standards. We need a progressive motoring taxation system for the foreseeable future, and we need to support individuals and businesses to shift to cleaner forms of transport. And we need further investment in the charging infrastructure as a priority. And we also need to encourage fewer, not newer vehicles on a mobility as a service basis. So councils and towns now are looking at putting in more cycleways, more walkways. They're looking at ways of being able to share vehicles, of moving people onto buses, etc., etc., rather than just having more and more cars. So it's fewer and more smart ways of planning that transport in the towns. So from a taxation point of view, the plug-in grant is currently £3,500 and a cap is being considered above £60,000. Plug-in hybrids, the grant is currently dropped, but that's expected to be extended in the next budget. And we need a way of moving from internal combustion engine vehicles through plug-in hybrid to full battery electric across the next 10 or 12 years. Benefit in kind tax calculations are emission-based, and the benefit in kind rate for battery electric vehicles is expected to be 0% from the 6th of April 2020. And workplace charging for employees who own their own electric vehicles will also be exempt from benefit in kind charging. And the same with VED. If you're emitting less than 50 grams per kilometre of CO2, you will be exempt from paying VED from April 2020. So, what operational actions can I take to green my fleet? Fleet managers are tied in to long-term vehicle procurement contracts. Vehicle replacement dates are well out into the future. We need a rethink on diesels. How and when are we going to phase out those vehicles? And if you think about the life cycles, 8 to 10 years, we're going to go to at least 2 life cycles to 2035. Diesel Euro 6 vehicles are still considered clean for high mileage motorway operations. And we need to consider the impact of residual values for older vehicles and for Euro 4 and 5 trucks. So the values of those and the depreciation are changing as more and more clean air zones become available, and there's more taxation on those type of vehicles. And don't forget your plant operations. If you're operating forklift trucks in warehouses, battery operation should suit that operation, and that would be far better than an old diesel in the back. And what can we do to improve our emissions of our current fuels? So our current fuels and our current fleet, we work with Thomas Group, who provide diesel additives and technology, and they can show some significant reductions in emissions, reductions in maintenance and DPF and ERG technologies, and fuel savings above 5%. So by working with some of these additives now, there is opportunities to reduce the impact on the environment and become cleaner. And finally, grey fleet vehicles versus hire vehicles. From a grey fleet perspective, the BVRA, on average, from their members, the hire vehicles they provide are on average 5 months old, compared with well over 3 or 4 years usually for a grey fleet vehicle. So hire vehicles are and could be a much better option for companies that are paying employees grey fleet values. Okay, so fuel types. CVs versus FCVs, or as the Chinese like to call them, new energy vehicles. We're talking about new energy, etc. for these vehicle types. So, battery electric vehicles, what are the benefits? If they're used in a mainly urban environment, they're light duty or low distance, and the operations is back to base on a daily model. You can also get home and workplace charging availability, and they're probably now cheaper to operate than internal combustion engine. The tipping point is here when total cost of ownership is considered versus outright purchase. And for some of those tax reasons I mentioned earlier, 40% less moving parts than an ICE vehicle, so considerably less maintenance costs, tax costs, etc. If we're talking about total cost of ownership, the business case is there for a battery electric vehicle. So the barriers, what challenges do we have? Can the EV supply match demand? Range anxiety below 200 miles, and the charging infrastructure, that development is required. And when we think of charging infrastructure, we're thinking of posts and we're thinking of cables and plugging things in. There's significant work now also going into Wi-Fi charging. So in America, there's one bus network that has extended its range from 170 miles or 140 miles, sorry, to 240 miles. And what they're doing is halfway around the route, they will go onto a wireless charge at a depot, and that's a good range extender. So expect to see a lot more options with charging infrastructure through wireless charging as well as posts. Longer charging times are required for BEVs, and currently they're more expensive to purchase. But again, when we look at supply versus demand, battery electric vehicles use lithium. And while there's still a supply of lithium, and most of it's coming from South America, the amount of lithium required to fund the amount of battery electric vehicles that is needed is a challenge. And by 2025, there's expected to be a lithium bottleneck for BEV car production. Not only if we can get the lithium out of the ground, but it's the battery production upstream. There's projects coming online for battery production. They're not being funded quick enough. And if we're going to hit significant vehicle numbers by 2025, those plants will need to be in place. So battery vehicles are a great option, but we have to recognize that supply and demand are going to cause people issues when they're trying to purchase those vehicles. So what about fuel cells or hydrogen as an alternative? Much longer range and quicker to charge. Smaller batteries, so we've got less weight, more payload, and we can decarbonize production via renewables. So that's really important as we move forward for wind, solar, and wave production to store hydrogen. So to make hydrogen, we use electrolysis to split water into hydrogen and oxygen. And via renewable energy, we can do that and store that hydrogen in tanks. So if I have a battery electric vehicle, I'm on the grid and we're using coal or nuclear energy to produce that electric, I'm still not carbon neutral. I may have better tailpipe emissions and less NOx that harm the people, but I'm still pushing CO2 out into the environment and creating carbon. Where if we're with renewables and we've got excess wind power, we generate electricity, which we can then use to create hydrogen, and then we store that hydrogen and use it in our vehicles. It's carbon neutral. It's the way to go. Hydrogen is also scalable across all our models of transport: cars, vans, trucks, and buses. And because of the longer range and the quicker to charge, obviously hydrogen looks to be a very good option for vans, trucks, and buses. And their fuel cells are 100% recyclable. So with all those benefits, what are our challenges? There's only 2 car models currently available that run on hydrogen. The technology is behind battery electric vehicles with regards to availability and infrastructure. The good news is the natural materials for fuel cells is platinum. So we're not just looking for lithium. Platinum is going to be the natural material for fuel cells. And another issue is the direction of hydrogen fuel and networks may not become clear until 2025. And there's certainly some large projects in the UK and across Europe to develop that hydrogen network, across the major pipeline of truck journeys across network. But again, that network and the fueling options and how we are able to move hydrogen and store hydrogen is the main issue at the moment, and governments are supporting some of those tests and development. So, how are we going to prepare our fleet for sustainability? What actions can we take? What we do know is that most vehicles now in the future they're going to be connected, they're going to be autonomous, they're going to share services and platforms, and we're moving to electric mobility. So, before we invest in EVs, we need to prepare your fleet data. So how clean is that data? Does your data exist in spreadsheet or silos? Do you have any single points of failure? And to answer those questions with your data, we need to understand, can we create a strategic capital replacement plan for the next 5 to 15 years? Do we need to consider three-way moves due to CAV site proposals? So if I have some new vehicles and they're due to go into major cities, we may push all those into London at the moment because of the ultra-low emission zone. We may have 2 or 3 year old vehicles in London that will have to be moved out of London into those other cities, and the oldest vehicle on the fleet is then sold. So there's some challenges there for certain types of fleet. When's the optimum vehicle replacement time per vehicle? And should I repair a current vehicle? Can I refurbish it or replace it with a low emission vehicle? So, automated life cycle cost analysis and replacement planning with our capital asset management product, and how can that help you? So, first off, this is a life cycle analysis we can. Now, we currently in the UK have probably 100,000 records on our system and 10 years worth of history. And through this process, we are actually, one of our customers is using replacement planning to buy battery electric vehicles, and they are being moved into the ultra-low emission zone in London as we speak. So, what's a life cycle? This asset life cycle is based on a category, and a category is a vehicle type of a similar size, specification, cost and age profile, and operational use. So, the mean equivalent average cost, this is the finance look at the asset life cycle, and it's looking for our lowest NECE. So in this example, the blue line is depreciation, double decline in depreciation, and the purple line is our operational costs. And if we looked at the NECE, it's telling us for this type of category that we should replace in year 10 based on the financial analysis, and it's within 5% in year 9. So, just breaking that analysis down a little more, our cost trends. So we still have our double depreciation line. Now we split our operating costs out into low, medium, and high. And you probably can, or you may not be able to see it that well here, but our high costs, our high operational costs are crossing about year 9 or 5, and our low operational costs are crossing year 8. So one of the options may be to look at our high-cost vehicles. We may start to replace those in year 4 or 5, and our low-cost vehicles in year 7 or 8. And this analysis just gives you more and more things and options you can look at. Now, if we now look at our utilization, we can see that after year 7, the utilization or mileage of those vehicles is dropping. And this analysis on this category is on a vehicle probably doing about 100,000 miles a year. But what we do know is as vehicles get older, drivers don't want to drive them. There's less of them as we start to sell them, but they still incur maintenance. So we can certainly see that the utilization is dipping. Now, if I go and look at the operational costs, so now a lot of finance people, a lot of operators will want to know, well, what about the operational costs of the vehicle? And you can see now when we do this analysis, because we have lesser utilization, we have less vehicles, we still have a lot of maintenance. And this is telling me now on pence per that I probably should start to replace these vehicles between years 7 and 8 as my maintenance costs start to increase significantly. So with CAN, we can run lots of life cycles, we can run lots of analysis based on the historic data of the fleet to help us identify the optimum time to look for our life cycle replacement. And I can also build a baseline forecast for a capital replacement plan. So this is my fleet based on my categories and the replacement parameters I've put in there. And it's given me the forecast for the next 12, this one's running for 13 years. The red line is the replacement expenditure. As you can see, in 1919, I'm having a tail. Most of our customers have a tail, which means some of the capital decisions that we made, we've got overdue vehicles because we starved the capital, and they will incur more revenue or maintenance costs because the fleet's too old. And what I'm doing is I'm looking across this line, and in 2020, I don't need so much capital, but within 3 years, I need double the amount. So what we need to look at is how do we smooth this line based on life cycle 1 and life cycle 2. So when we want to get to 2035, we're going to run through 2 life cycles, and we need to consider how we smooth this line. And also then, if I'm going to move to battery electric or alternative fuel vehicles, they may cost more. Against my replacement categories, I can add those additional values of buying those vehicles, and I can run those scenarios and look at my capital plan, take that to the board, and explain how we're going to run through 2 life cycles. And as we said, diesel, hybrids, before we go new energy, and the scenarios that can be done using this tool. Here's just an example of another baseline plan where a fleet is probably replacing its cars at 4 years, it's around at 8 years, and its trailers at 12 years. And you can see every 4 or 5 years we get a spike. And obviously, what you want to do is try and understand what capital you've got available and smooth those lines and those replacement parameters across your fleet size. So on to scoring. So now we've had a look at our life cycles. We've now had a look at our forecast, and I've actually produced a replacement plan. So this is the individual assets on my replacement plan. Here's the category, and over here you'll see a score. So even though we've got our replacement dates and our parameters against this category, against every asset we can set a number of scores, or scoring types and values that we can then weight as part of a process. And basically, the higher score vehicles are probably our worst. So, you know, we can look at age, utilization, energy use, condition, maintenance costs divided by age, number of work orders, or work order costs in the last number of years. So there's 40 or 50 parameters and scoring criteria. You might take the first 4 or 5 or what your business determines that we should use. And fundamentally, when we run the analysis against the maintenance, is scoring and weighting those vehicles. And as you can see here in this example, this is the forecast date, here's the plan date, and we've smoothed this plan to replace vehicles of the same category across 3 different years based on its operational condition. And you can see this one down here, which due in April 2015. We've pushed it out because it's got a better score than some of these others, and that allows you to spread that replacement plan and do all that analysis prior to ordering your vehicles. So we believe that you'll be able to make much smarter decisions we can. It's the ultimate source of truth for fleet, vehicle, and asset data. We should be able to do away with a number of spreadsheets or data silos, and it integrates with your fleet, ERP, GPS, and your systems. So if you'd like to schedule a free demo or contact us, as our address is assetworks.com/UK/CAN, and we'd be more than happy to discuss and help you. So that's it for our webinar today. I hope that's been informative and beneficial to you, and we can take any questions if you have any. Thank you.
Yeah. Thank you so much, Nick. That was really informative and great. So we're opening up the floor now to some of your questions. So as a reminder to all of you, if you have any questions and haven't sent them in yet, you can send them to host using the WebEx chat tool on your screen. Provided that we have enough time, I'll pass your questions to Nick, and he'll be happy to provide an answer. So Nick, we did have a few questions come in for you during the webinar. So the first one is the screen you showed with the capital forecast. The attendee noticed that you chose 15 years for the length of the forecast, and he was wondering why.
Okay, that's a very good question there, Marianne. Thank you. So the capital forecast was really based over the 15 years. It's because, you know, looking at the replacement cycle now, we have 2 cycles. So we've probably got an 8 to 10 year replacement cycle, and then we'll be in our second cycle before we get to 2035. And what we need to be doing is looking across that period of time to be able to determine how we're not only going to build a more sustainable fleet, but look at the impacts of the costs over those 2 cycles of delivering that fleet and doing the necessary analysis to support that. I hope that answers the question, Marianne.
Yeah, for sure. And then just one more question. It's kind of like a twofold question, but you know, you talked a great deal about BEVs and FCEVs, and the attendee was wondering if the United Kingdom, do you think that they're ready for these BEV and FCEV goals? Do you think they're set up properly with the charging infrastructure for both at this point?
The charging infrastructure continues to develop. The work we were doing with councils and the Association of Public Service, excellent councils, they're all now looking at putting charging points in and supporting electric vehicles. The range is still an issue. There's a great example up in Dundee where they significantly put in lots of charging points. They have renewable energy on their car parks, on their roofs. They encourage people to park out in town. If you have a battery electric vehicle, the parking is free out of town. If you want to park in the centre, the charges are much higher. And then as they move people out into those car parks, people can charge their vehicles. They can walk in or they can go in on the electric bus. So there's some great examples of some cities that are already ready. And there's obviously examples of other people who are trying to catch up. But significantly, you know, everyone is now looking at moving to the battery electric vehicle technology. There's still some work to do.
Yeah, definitely. Well, thank you so much, Nick. Those are all the questions that we've had so far. So at this time, I would like to thank all of you again for taking the time to attend today's presentation. Hopefully you've all secured some really valuable takeaways to keep in mind moving forward. Nick, I would also like to thank you on behalf of AssetWorks for sharing your expertise with everyone today. As you can see, some contact information is available here for Nick, so if you have any follow-up questions or concerns. So thank you all for attending today. Nick and I are going to stick around for another few minutes in case there's any questions that you want to send in, but otherwise, have a great day, and we look forward to having you with us next time.
Thank you.